screen now.
Okay, perfect. You see my presentation here? Okay,
Yeah.
awesome. Well, yeah, so great to be here with you all today. Thanks for the patience with a little bit of technical difficulty. My name is Jack Edgar, and I'm a researcher at the University of British Columbia in Vancouver. And yeah, I'm going to be speaking today about the opportunities and applications for biochar in animal agriculture and how it can be a tool for resource circularity with cascading benefits. And I think it will really complement well with what Katerina was just sharing with us, as composting is no doubt one of the best ways to be using biochar in agriculture. And so this is one of my favorite definitions of biochar. People ask me all the time, what is it? And it is a charcoal used as a soil amendment or for other environmental management purposes. And down here in this photo, this is sort of the typical feedstocks that we're looking at investigating here in British Columbia. The amount of timber waste from the forestry industry is pretty outstanding. And really, it's a combination of the cost of removal and the vastness of our province. Some of these places where they're logging are just so remote that bringing all this material out is, at the moment, not cost effective. So sadly, they're piling it and burning it in these massive slash piles, obviously emitting lots of carbon, air particulate emissions, etc. So this is kind of what we're focusing on, is like, how can we pyrolyze this material to make a high quality biochar? Won't go into it too much, but as it was mentioned, the terra preta soils of the Amazonia are really what stirred all the scientific interest. And I think it's really important to recognize that indigenous communities all over the world have used charcoal as a tool for environmental management and soil remediation and improvement for millennia. And it's really important to recognize those origins of biochar. And even here in British Columbia, we were exploring some indigenous sites with some of the local First Nations last week here around Vancouver, and finding some North American style terra preta soils of these 3 meter deep organic soil horizons that were just unbelievable compared to what you're seeing in the conventional proximity forest. So the physical properties that we're most interested in for its applications with this are its large surface area, high stable percentage of carbon, and the porosity and the variable pore sizes as well. And then chemically, it's got the high cation exchange capacity, an alkaline pH, negative charge, functional surface groups, and electrical conductivity. And so all these things are going to be important to consider when you're designing or developing your biochar for its use in animal agriculture. And I think one of the most important things to consider and take away is that biochar is not biochar, and that the properties vary widely based on what you're making it with and how you're making it. And it depends on the application, but for agriculture, it's really important to consider these variables, as you're going to have drastically different outcomes with how it functions in your soil. And this is just a small graphic, comparing a grassy versus a woody feedstock and how that affects the porosity, and then over a temperature gradient as well, to kind of illustrate that point. And then here, it's so variable, but I found this one schematic that I like that kind of compares a number of the parameters: the surface area, electrical conductivity, pH, the carbon storage. And these authors found that between 550 and just over 600 is kind of the optimum range to maximize all of the parameters that you're looking for. But once again, this should be taken with a grain of salt, and it really depends on what you're making it with, and also the heating time, the residence time, and then what sort of equipment you're using. But it's just a kind of a rule of thumb that can help guide decision making possibly, and and further experimentation should be done in your own situation. So as we know, agriculture is a huge contributor to climate change. By some estimates, up to a quarter of all global greenhouse gas emissions are coming from agriculture. And of that, 70% are coming from industrial animal agriculture. And as we've continued to confine and conglomerate these operations, we have huge issues with manure management and manure mismanagement and nutrient loss and nutrient waste. And so this poor planning makes manure a waste source. And so we have issues of nutrient leaching, nitrates and phosphates pollute freshwater systems and aquifers. And this nutrient loss requires a greater use of fertilizer and manure application. And then we also have the issue of air pollution. So not only are the most potent greenhouse gases such as nitrous oxide and methane coming from these concentrated manure situations, but we also have ammonium volatilizing into ammonia, NH3, and then this is fusing with air particulate and other gases and creating these ammonia salts, and we get these white haze, air pollution. This is an issue definitely where I'm living in the Fraser Valley in Vancouver. It's an area of very dense animal agriculture and not great manure management. And so biochar can really be used as a holistic resource management tool to improve our management of manure and turning it from a waste source into a resource. And so there's 6 main uses of biochar that can be done in animal agriculture, and I'll just go through and give a brief description. Obviously, there's so much to dive in on each one. The first one being anaerobic digestion, so the production of biogas through the anaerobic decomposition of manure and other biomass. And so by incorporating biochar into anaerobic digestion, you can have some improvements. The second is to use as a bedding material in barns or pens for animals, and just really thinking about using it as a sponge to absorb those nutrients and keep those nutrients in our agricultural system. And then, of course, as a co-composting ingredient, as we already learned in the last lovely presentation, such a great use for it, no doubt. As a feed component for animals, just a very small percentage, a feed additive for animals. As a tool to manage liquid manure, so manure slurry and just pure liquid manure, and using it either as a cap or a sponge for that. And then lastly, actually producing biochar from manure is the last main use. So I'll go into a little bit more detail on each of these now. So as I mentioned, first and foremost, the anaerobic digestion. And I feel so grateful to be living in a time where there's now a decade at least of really popular or increasing popularity of scientific literature around biochar. So, we can see over time the trends that it's increasing the actual methane and biogas production. And the thought is that it's improving conditions for methanogens to do their thing. And also we're seeing a decrease in impurities like hydrogen sulfide and ammonia. So overall increasing the productivity and efficiency of methane production for biogas. Secondly, as a barn bedding, I think this is one of the best uses of it in the intense animal agricultural setting, and incorporating it at about 5 to 10% of volume of the bedding. But also there's a lot of literature pointing to the importance of inoculating the biochar with lactobacillus bacteria, or another, you could also acidify it in other ways to bring the pH down of the biochar. And by bringing the pH down, that will really reduce the volatilization of ammonia. And that improves the odor, that harsh smell we get from concentrated manure. That often is the ammonia production. So we can improve the odor, improve the barn conditions for the animals. There's even evidence of reducing hoof disease in animals. And one of the really cool things from a nutrient perspective is by incorporating it early on, even before we get to the composting component, by having the biochar in the bedding, we're increasing the nitrogen to phosphorus ratio. We're holding on to more of the nitrogen that would normally be lost in ammonia or lost from leaching. And then an issue is that in a lot of agricultural systems, there's this huge buildup of phosphorus because so much nitrogen is being lost throughout the whole process of manure management. And by the time it's applied to the field, they have to apply a huge excess of manure or compost to meet the nitrogen requirements. And then you have this huge buildup of phosphorus leading to issues in environmental eutrophication. And so, yeah, less compost required to meet the nitrogen crop demands. And that leads to a reduced cost of application and leaching risk to agricultural systems. And then co-composting as well. Of course, I'm not going to go into this too much, but as we just had a great presentation about it. I mean, my breadth of literature that I read ranged from 3 to 20% of biochar by volume. So I think, Katerina, what you said about 10 to 20% is spot on. And I found it. The reason I asked about volume versus mass, I found the literature kind of varied in what people use to measure, which would be nice if we were a little more consistent, but I think you're spot on. Yeah, and additionally, it's mitigating greenhouse gas emissions during that process, essentially by just keeping more nitrogen and carbon in the compost. We're losing less of those elements in the form of methane, nitrous oxide, ammonia, hydrogen sulfide, and also helping improve reduce the toxicity and the pathogen content in the finished compost of the product. And then as a feed additive, it has some pretty cool historical use. Actually, of all the literature I read, this is the most historical use of biochar in Western agriculture systems, or charcoal, I should say, is using it as a feed additive in dairy operations, and finding literature going back hundreds of years showing this. And so I'd say the main benefits are improving animal health, improving the feed efficiency, so optimizing the weight gain per day. And this is really only 1, maybe 2% of total feed. And it's certainly really critical to consider the quality of biochar for this. This has to be the highest quality biochar, no, polycyclic aromatic compounds, no heavy metals. And in the EU, there's the great system of the EBC, I think it is, of ranking biochar qualities. And unfortunately, in the US, the FDA has not approved it as an animal feed, and same here in Canada. It's only approved at a minute application rate, just as a coloring agent. So hopefully these are things that we can get changed here. And then lastly, there's one study. Yeah, it's an incubator trial, so not an actual, proven at scale concept, but there's a potential for it to decrease the enteric fermentation and methane production. But I wouldn't really go on that and market that as a benefit, because it's really yet to be proven in science. And the thought is that it can act as an electron donor or receiver during the whole biodigestion inside the ruminant's stomach, and that's where it's reducing the methane emissions, but to be determined still. Liquid manure management, this is a big issue around here where I am. As I mentioned, there's a high density of dairy farms and poultry farms, and with that, all this manure slurry and liquid manure is stored in these big lagoons or ponds. And so using biochar as a cap for these lagoons can reduce the ammonia and the odor, or simply using it as a mix to absorb the nutrients and the liquid from these liquid manure management systems, and then being able to deliver those nutrients over a wider distance too, because sending just a liquid fertilizer is very expensive. And secondly, when the liquid manure is broadcast applied to the field, so much of the nitrogen is being volatilized into nitrous oxide and ammonia pretty much right off the bat. So it can act as more of a slow release and more sustained fertilizer that's explored over time. And then lastly, producing biochar from manure, I think, can be a pretty cool option when we're in situations with really a lot of surplus manure and there's not a destination for it, and we're seeing these other environmental issues coming along with excess manure. And so, there's increasing implementation of manure separating systems that separate the liquid and the solid, and then the liquid can be used as a fertilizer or charged with biochar. And we're seeing these huge mass reductions between 42 and 86%, which really can lead to a greater traveling distance of manure. And as in terms of a biochar, what kind of biochar is manure making? It's making one with a relatively low surface area and low porosity, but significant nutrient content in terms of NPK, and that certainly has a benefit in terms of an agricultural fertilizer. And so here I'm going to get into sort of the idea of the cascading benefits. So animal agriculture can actually, or the manure from animal agriculture can actually improve the qualities of biochar. So there are some negatives to fresh biochar, which we have to acknowledge in an agricultural setting, especially in temperate soils. Tropical soils overall, can see a lot of benefit. They're more weathered, there's less nutrient content, they're pretty sandy often. And in a global meta-analysis, Schmidt et al., they found that there was no increase in yield from biochar in temperate soils, so in more northern latitudes. And the thought behind that is that it's tying up nutrients when it's being applied. The carbon is locking up some nutrients to be used, and the intense pH change can sometimes negatively affect some of the soil function and soil processes in such a short amount of time. And it can also be hydrophobic, so it's repelling water when it's first being applied. So this is fresh biochar that's not aged at all. But when we have aged biochar, which can be aged by the integration of animal waste, and composting can help age and enhance that process, we start to see some of these organo-mineral associations forming on the surface of biochar. So we're preloading the biochar with nutrients, with microbes, increasing the surface functional group, so really enhancing its chemical capacity for a lot of the things that we're wanting to see it do, and then changing it from hydrophobic to hydrophilic, so it's starting to love water and improve its absorbency capacity for water holding, which is really critical in terms of its agricultural and agronomic use. And so here is a small demonstration of some. Not only have I done an extensive literature review, but now I'm working on a field project here out at UBC. We're just about to start our second year of field trials, which will be cool to see how it's changed over the last year, as we didn't apply any more biochar this year. But we're comparing a fresh biochar versus one that was charged with a dairy manure slurry. So a manure slurry is sort of what's just sprayed off the barn floor, these concrete barn floors. It's mainly liquid, like usually over 90% liquid, with a bit of residue solid manure and maybe feed or bedding material, but it's mainly a liquid manure. And so we're observing the nutrient and water dynamics in these soils. And you can tell here in the very first little plot, there are 4 by 5 meter plots, and this plot right in front of us here is one with charged biochar, and then the plot just behind it, if you can tell, is a fresh biochar. So it's a pretty distinct difference. And here's a photo of the wheat heads. We grew a spring wheat variety, and on the left you can see the fresh biochar, these small kind of stunted wheat heads compared to the biochar charged with dairy manure. And so we're still processing through our data, but I mean, visually speaking, the change was obvious. And so here's my vision of how it provides cascading benefits. So it can improve the sustainability of animal agriculture by reducing the greenhouse gas emissions, the nutrient leaching to the environment, and we're capturing those nutrients to then enhance the properties and the function of biochar. And then we're applying this enhanced biochar as a soil amendment, increasing the water and nutrient holding capacity of the soil. And then these improved soils by biochar are increasing crop and pasture productivity, leading to, more biomass that could then be used, crop residues to increase the production of more biochar in the future. So yeah, in conclusion, I know he's a controversial figure, but I think I like this quote. It's hard to argue with it, by Alan Savory. No resource can cause a problem. It's how you manage the resources that cause the problem. And so the same can be true for manure, and the same can also be true for biochar. It's really important, I think, to consider it in terms of the holistic picture of your region. Is biomass readily available, or are we starting to grow lots of crops to produce biochar and replacing food production with bio production? And that's something that is concerning, and I think it must be considered within the whole picture. Secondly, it's highly variable. As I mentioned, the properties are highly variable, and for agriculture, especially in temperate soils, I think it's really important to consider that variability and how we can optimize and maximize the characteristics that we want to see. And lastly, my personal view is that we, in regenerative agriculture, we really need to be investigating and developing more systems for actually integrating animals into cropping systems. So, I mean, a lot of the things I shared today are based around animals being kept in high density and high containment. And to be honest, that's always going to exist to some degree. Like in a lot of ways, it is very efficient. But I really think the optimum level of agronomic integration with animals is by integrating them into cropping systems of rotational grazing and depositing their nutrients and manure back into the system that way. So my recommendations at large are that we need to be consistently characterizing the qualities of biochar, both producers and researchers, because otherwise we're not comparing apples to apples. If we're comparing things with wildly different properties. I also would love to see more farm scale research. So much of the data that I went through is, small lab trials, incubator trials. And so really seeing more farmer-led research with academic partnerships and support to get that real world vision and data growing and spreading within the farming communities around the world. And then lastly, that if we're integrating biochar into the soil for agriculture, I think it really should go through animal agriculture to have these compounding benefits that I shared. So that's it for me. Thank you so much for your time today. And if there's any questions, I'm happy to try and answer them now. Yeah, Katharina, did you have a question?
I just want to appreciate that was a very great presentation. Thank you so much for summarizing all of this different research on how you can integrate biochar into animal agriculture, and especially about highlighting that it can cause a problem,